Well, whatever you lack in scheduling complexity, we make up for. So we're going to find out about this in the talk here. And also keep an eye not only on the slides, but also on Brome. He might start twitching at some point. So I'll talk about how we do a combination of two vastly different workloads over at NASA Ames at a slight scale. So here's a breakdown of what we do on an average day. We've got about 12,000 compute nodes. Each one has a PBS mom on it. And just some of the sort of baseline pieces of how we operate. So nodes are dedicated to jobs, right? It's default exclusive for sharing. And then the jobs we have running at one time, 200 to 500. And that's it. That's apparently very small. And then 100 to 400 queued jobs. So actually, I was thinking also, QStat is just useless to you, right? 50,000. So then the way our system works, so the scale of nodes that we have and the size of jobs being run, it basically ends up giving the scheduler all kinds of heartache. So in a bad day, we might have a long scheduling cycle of 10 minutes, 15 minutes. And then if you don't know it, there's a built-in limit at 20, at which it gives up. So we hit that every so often too. But on average, what we see for our scheduling cycles is between 2 and 5 minutes, okay, somewhere in that ballpark. And when the scheduler is doing its thing, the vast majority, probably 90% of what it's doing is the top job analysis. So if you're not familiar, there's a way in PBS scheduling configuration to say backfill depth equals some number of jobs that you want to set aside resources for so that they can actually run at some point in their lifetime and not just wait forever while short jobs get run first or smaller jobs get run first. And then again, to make things work at our scale, we do not do job preemption. So jobs are an inviolable entity. You don't break them apart, make them stop. The different workloads. So the way I call it again is batch and quick turnaround. Batch, we consider them to be either very, very long jobs or a whole bunch of medium length, even short length jobs where you can basically just set it and forget it, right? Just throw it in the queue, walk away, go on vacation for a while, go do something else. And that's the vast majority of where our CPU hours go. And then quick turnaround it effectively becomes the prefix to batch, okay? So we had either people doing code development or they need to go out and actually run on the nodes to see how it's going to work, or they need to go out and do their pre-processing and actually run jobs to set up for a big batch run. And then the way that I describe these jobs is warm body jobs, okay? So we have this queue devoted to this purpose called the Devel queue. I'm going to use that the rest of the talk. And the Devel queue would limit a person to one running job at a time. So we really expect them to be actually sitting there at their desk doing something with this job, either interactive or they're running a short batch job and they're going to get output and deal with it. So the problem that we have with the length of cycles that we have is you basically get what I call threshold to coffee break. Okay? If you're running an interactive job or you want to submit one, how long are you going to wait, realistically, for the prompt to come back and do something? A minute, 2 minutes, 3 minutes? And it gets worse every iPhone release. Apple keeps messing that up for us. So the young kids these days are expecting 5 seconds, maybe 6 seconds, something like that. So how are we going to accomplish this? So first approaches that we took, so there's one obvious one, which is set aside some nodes for this purpose. So they're open. You can actually get them in pretty quickly. And so we did a standing reservation, and again, modeling that on when people are available to actually do work. So Monday through Friday, working hours, taking into account West Coast, East Coast, where our users are. That is good for freeing up nodes, but not good for solving the cycle problem. So then we went into a different approach, which was that maybe users are willing to actually stay awake later, wake up earlier to do this. So let's just make it available 24/7, okay? So we do that, and again, this ends up being an obvious trade-off. You're not going to be having lots of empty nodes at midnight, dark 30 in the morning, but it does make things easier for the scheduler, not having to deal with reservations all the time. That's going to be one reduction in scheduling headache. But again, still not solving truly the scheduling cycle problem. It's still going to be 2 to 5 minutes on an average cycle. And if you think about it, so you as a user want to go in and do a batch job. You throw it in the queue, interactive job, quick turnaround. Throw it in the queue, you might have arrived just after a cycle started. So you're going to wait potentially 2 cycle lengths to get your job started. So now you're looking at 4 to 10 minutes, okay, to wait for your job to start. That wasn't going to work. After enough grief was given to us by certain users, some of our own staff who have to use the system, they basically pushed for, let's make another PBS server instance. Let's actually set aside the nodes that we have for this purpose in a different complex entirely. So the schedule is going to be lightning fast. It's going to be 1 second, 2 second cycle to accomplish this. And here are the results. Users love it. It's great, perfect. And then admins hate it. Dale and I and David, now we've got double the work to administer 2 systems. Not only that, there's times where you might want to move nodes back and forth. That's a big pain in the butt. You just kind of go down the line of things that are difficult for an admin in that scenario. And management's somewhere in between. They don't like unhappy admins. They like happy users. But really, this loss of flexibility that we have to grow and shrink the Devel queue according to demand is a big negative. We really want to have a way to get back those nodes when they're not being used and add them as we need them. So what's a better way? So we need to get back to 1 PBS server. That's pretty obvious. And we have to deal with the problem of scheduling cycle, also obvious. So why not just cut the scheduler down? Just stop a cycle. I got a job I want to run. Let's just stop what you're doing, go to the beginning again, run this new job. And results of that, we're going to have, ideally, more quickly, starting the Devel queue jobs. And who gets to pay the cost? It's the batch jobs. They're going to have to wait longer. If they were just the one just about to get started by the scheduling cycle that got cut off, they have to wait however long. But our assumption is they won't notice. And if they get angry about it, we tell them, too bad. So the one big assumption that makes this whole scheme work that I'm going to describe is that we have to actually have nodes assigned available free for this purpose, for the Devel queue. And that's really what, fundamentally we have to have to get quick turnaround. You have to have free nodes. So given we can go in there and modify the scheduler, we do that. And here's the basic steps of it. So we have a new mechanism in the scheduler that can accept a signal and stop the current cycle, start a new one. And it does that very quickly, 1 to 5 seconds. It's pretty quick. We use a hook to actually issue that signal to the scheduler. And that hook, I'll get into a little more later, but basically it's a queue subhook. Now, these mods tend to beget more mods and beget more mods and beget more mods. So now we have a chance to DOS the scheduler. We could have a user going in there throwing in jobs that are 2 seconds in length each, and we're going to get nothing done ever. So we have to add a couple more parameters in to deal with that. We now have a minimum cycle length. And in our case, we end up picking 30 seconds for this. So our overall goal is we want to have a scheduling cycle of about a minute in length. So if we're allowing it to do half of what we theoretically want it to do, we should get some work done in that time period if we have to do an interruption. And then we add another parameter to allow only a certain number of consecutive interruptions before we go off and just do a full deep dive cycle. Look at all the jobs that have been collecting in the time period we've been interrupting cycles. So now we get into the really fun part. Back to scheduling complexity. So we have 3 or 4 different job sort keys that we use. And there's even a couple implied ones, so maybe it's more than that. And now we've interrupted sort of the purpose of that in one sense. We now have to do a new way of saying that this job that just came in is going to be at the top of the sort list in some way or fashion. So here we go with the job priority game. So first of all, let's start with a hook. The hook that issues the signal to the scheduler needs to do it at the right time. So this ends up being the embodiment of our policy for what is a quick turnaround job what is it that needs this treatment. And so given it's a signal, it's going to tell the scheduler one thing only: start a new cycle. That's it. We don't get to know what job it was that actually caused this to happen. And the hook, so therefore has to be smart enough to say only really the ones that we want should go off and do this, because we might end up doing things in a different order with this new cycle. It could go any different direction, really. Now, the real problem out of the initial problem is that our sorting does lots of things to get, of course, important jobs to the top, and then that important job to the top piece ends up feeding into who you end up backfilling for, okay? The top jobs you end up picking. And if we don't do this right, we're going to end up basically putting either some number of the Devel queue jobs or all the Devel queue jobs into those backfill slots. And that's going to be just a terrible, massive increase in the scheduling cycle length. We have to somehow not allow the Devel queue to take over those slots from other jobs that would have been picked for that. So here's another mod that gets popped out of that. We end up making a separate pool of top jobs devoted just to this purpose, just to our Devel queue uses. So we end up setting a queue level flag to basically denote a certain queue is eligible for the separate pool. We have to allow setting of how large the pool is, et cetera. And then that pool itself, if you think about it, it's again allowing more top jobs than you would normally do, and so you have to start trading off the benefits of paying that top job cost for the Devel queue jobs on top of the rest of the backfill depth jobs you would do for the batch workload. And then, of course, we can't stop there. Another one to go ahead and implement is that in our Devel queue, we want to basically treat them differently. We want to have a different system of fairness for those jobs. We don't want to do our default policy, which is to favor large jobs ahead of smaller jobs. And so we go ahead and add yet another queue level resource to the Devel queue and say, go ahead and ignore the node count as a sort key and treat them all the same. So there's where the game went for sorting and priority. Now here's the example I'm going to work through. This could have taken half an hour, but we'll see how far we get. So we start off with, obviously, cycle A. It's going through. If anyone's sat there and just watched the sched log, okay, you'll be able to follow along pretty well. So here's cycle A. It's going through, looking at jobs, top jobs, regular batch jobs. And then a signal comes in from our hook because some user has submitted a new job to the Devel queue. And by the way, for our policy for that, so you can't already have a job in the Devel queue and get this treatment. You have to just put in your first job to the Devel queue. Because, I mean, you're a warm body. You only have one brain. You can only focus on one thing at a time. That's our philosophy. So we interrupt cycle A, proceed to cycle B. So now our mod to the scheduler says, go out and start looking at the Devel queue first. Okay? And so that is going to apply to every schedule cycle, not just the ones that get interrupted. It's going to go off, look at the Devel queue, and off it goes. Looks at job D1. It can run that one immediately. It goes off and does its thing. Looks at job D2. It cannot run. So now it's going to say, okay, I've got a job from the Devel queue that cannot run right now. How many slots do I have in my pool of top jobs meant for this kind of a queue? And it's going to do J of those, separate pool. It'll run through and check out all those jobs. And then we're going to march on to all the rest of the queues, the batch jobs, and start looking at the top job logic for job B1 because it cannot run. So we're going to do that extra effort to figure out when it can run, and then up to job BK, K backfill depth slots. Scheduler marches on, does the rest of its magic to look at jobs, and we go on and start cycle C again. And so this really, it was kind of a mind-blowing thing for me to watch this happen as we put this mod in, because you just get used to the fact that every cycle is going to take 2 to 5 minutes, whatever the length's going to be. And now we're getting this case where you're basically having users just cut down scheduling cycles all over the place. Now we chose a value of 5 consecutive short cycles before we go ahead and do a full cycle. And we can get periods of time where it's literally 5 short, long, 5 short, long for a couple hours. And so you see that there's this requirement for the Devel queue type job is pretty heavy at times. Just the other day I got an email from a user expressing his grief at the fact that it no longer starts in 1 second, it starts in some cases, a few minutes for his job. I have some informing to do on how exactly this works, but he didn't mention the fact that when I looked at the logs, he actually had gotten probably 60% of his jobs started within 10, 15 seconds. Didn't mention that part, just the long ones. So I need to go back and give him some evidence, reasons that we've done a decent job with that. And now, what can we do next with this? What's the way to go forward? So again, back to having just one PBS server in play, we want to do the dynamic allocation and deallocation of nodes for this purpose. And that, in one PBS server complex, becomes just as easy as changing the queue attribute for a node. Okay? We can do that. That's scriptable, that's easy. And we also can get back to actually following an allocation and deallocation process that tracks with when people are awake, available, had enough caffeine in their system to be able to focus. So here's where we're kind of going with that. I haven't gotten to this yet, just put some thought into it. So if you have any ideas for me, please find me afterwards. One is just set basic target numbers, a number at 4 a.m., 9 a.m., 6 p.m., and let's say we're going to pick X nodes at 4 a.m. to be available, double that at 9, and then back to 1/10 at 6 p.m. So we have some amount available for nodes in this Devel queue. Of course, throw in an absolute maximum because we don't want 12,000 Devel queue nodes. And then go beyond that and have basically a secondary curve that tracks how many free nodes are available beyond the nodes being in use in the Devel queue. And that one's going to be, this kind of secondary curve that follows the first one. And that is where a lot of the playing comes in, because that's where you get quick turnaround. When nodes are available, you can start jobs quickly. So we're going to have to get an idea of how that curve looks like and how we can get less angry email from users. And then we get into the things we're going to have to figure out as part of that. So the nice thing about our statically set list of nodes for the Devel queue is that they're all in a continuous segment among our nodes. And so you get some of the benefits of the close topology between those. Can we maintain anything like that when we go to doing this active allocation deallocation process? This was brought up by one of our other staff members because they often use the Devel queue for benchmarking for that exact reason. They want to have that beneficial topology layout. And then what's the best mechanism for actually achieving, moving jobs around? We know we can do the queue resource value, but how do we actually go about and find which node to grab and when? Bill Nitzberg actually was the one that suggested throwing out high priority one node jobs. And as they get picked for that job, you just say, okay, your job is to reassign your resource and be freed again. One possible way to do it. And then to actually achieve this, you're going to need a certain rate of movement of nodes to make it worthwhile. And so we're going to have to experiment and see what kind of rate can we expect to have. Does it make sense to abandon at some point a desire to move nodes around because we're too close to a time period when we would actually start deallocating nodes, those kind of things. And that's it. Any questions?
So you mentioned it took the scheduler several seconds to respond to the signal, and I was wondering if you had it only responding at certain points in the processing, or
yeah, there's 2 points in the code where we added it. So there's one which is where the scheduler goes to the next job it wants to look at, And then the really important one is it has to look when it's in the middle of trying to put a top job on the calendar. Because you could wait a few minutes for a single job to be put on the calendar, and that defeats the purpose.
Other questions?
So how do you handle cases where there are two users who are submitting for the first time, have no jobs in the queue, and they need to have this interactive job now, go ahead and start right now.
Yeah.
But they submit, let's say, 5 seconds apart from each other. So at that stage, do you sort of reset the scheduling cycle for two users, or?
No, it really is quite linear. So the first signal will go out from the first user to put the job in. Scheduler will restart. And the scheduler basically immediately goes, talks to the server, and gets the list of jobs to look at. So it won't see that second job that gets put in. Okay? So the scheduler will have, again, that length of time, the minimum length of time to go through and look. And hopefully it'll be a long enough time to look at that first job that came in. And then just after the scheduler talks to the server, gets a list of jobs, it now gets a second signal. Okay? And so now it's going to go, okay, I have 30 seconds to do something, go through, process that, start another short cycle up right after that, and repeat the process. So it's first come, first serve for the user.
So just one more follow-up. I'm new to PBS, so I'm trying to get an understanding of how the scheduler is sort of independent with the job input layer. Now, does that mean that when you stop the scheduler, are there any interruptions, or are there any black holes into which new job submissions may get into and sort of be lost? Have you had that occurrence?
Bob says no.
Okay.
So the scheduler and the server process, which the server process is the one that all the clients talk to, maintains the integrity of your job, maintains the state of your job. That and the scheduler process are two totally separate processes.
All right. I'm going to hold questions there. Sorry, because we're out of time, but thank you very much.